So, good afternoon, everybody. Myself, Acharya Vishwendra, and today I shall be discussing a worksheet on the logic gates. So, let's begin with things. So, the first question is universal gates are. So, these are NOR and NAND gates. Now, is using NAND gate, make NOT gate. So, just make equal inputs, then that will function as a NOT gate. It can be verified by the truth table. Then we need to make AND gate using NAND. So this is NAND, combine it with NOT gate, so that will function as AND gate. Then we have to use OR gate. So for that you just make two NOT gates and their input should be fed to the input of the NAND gate, and that will give truth table equivalent to OR gate. Then we need to form NOR gate. So using this circuit up to here is OR plus NOT, so that will give the NOR gate. Next is XOR gate. So XOR gate can be made like this. We use the first NAND gate, and if the inputs are A and B, then the same input can be fed to another two NAND gates, and the output of the first NAND gate is to be fed into these two, and these together should be fed to another NAND gate, and the output here, let us say C, it will have same output as that of XOR gate. Then we need to make XNOR gate. So XNOR can be made by XOR, that is this entire circuit plus the NOT gate, which can be made by making the inputs equal. Next is using NOR gate, make NOT gate. So equivalently, just make the inputs equal, that will make a NOT gate. Then we need to make OR gate. So for OR gate, this is NOR plus this is NOT, so that will make OR gate. Next is AND gate. Similarly, we can say that take two NOR gates, NOT gates, and their input should be fed to another NOR gate, and the output will be AND gate. Then NAND gate. So AND plus the NOT gate will make the NAND gate. Then we need to make XOR gate. So as we used using NAND, the same can be done using NOR gate. Sorry, XOR. So for this, XNOR can be made like this, and XOR can be made by using this plus use the NOT gate over here. So using XOR gate, we can make it like this. Just start with XNOR gate. So XNOR gate can be made by this. Take one NOR gate and take the inputs as, let us say, A and B. Take another two NOR gates, and one of the input goes to the second and third itself, and the output of the first NOR gate is to be fed as input to the second and third gate. Both inputs should be given to the fourth gate, and that will correspond to XNOR. And using this circuit, we can make that as this is XNOR plus NOT gate. So the final output will correspond to the XOR gate. Next, we have half wave rectifier circuit. So you just take a transformer, add a diode, take a resistance, and take output across the load. So during forward bias, it will conduct, so high output, and during reverse bias, it will not conduct, so reverse bias output will be 0. We get half wave rectifier. Similarly, in a full wave rectifier, we use two diodes and a center type transformer, and load is connected between X and Y, and output is to be taken across X and Y. So during forward biasing, one of the diode conducts, another does not conduct. So we get conduction during forward as well as reverse bias, which explains the full wave rectifier circuit. So in this way, you can optimize your time and energy and can end up with flying colors. Thank you and have a nice day.